How you doing, everyone? Sean O'Kane here with ChipEstimate.com and ChipEstimate TV. We're here at DAC 55 in beautiful San Francisco at Moscone West. Let me tell you just a little bit about ChipEstimate.com. We're an IP portal, an ecosystem comprised of over 200 of the world's largest IP suppliers and foundries. And we're all working together to help this worldwide design community to become more effective and profitable by searching and exploring the most up-to-date silicon-proven IP available on the market today, which is all listed on ChipEstimate.com. And that's why I have this gentleman here, Mr. Kelvin Low, the Vice President of Marketing in the Physical Design Group at ARM. Thank you very much for being here.
Thank you for having me.
Oh, yeah. And ARM has their complete IP catalog listed on ChipEstimate.com as well. So, our topic today is transforming your next application with optimized ARM physical IP. Now, this is your first DAC since you've joined ARM.
That's right.
Because I remember seeing you at, were you in Austin?
Yes.
Okay. And I got the word that he's making the big move. So tell me what's new and exciting at ARM in the physical design group world for you now.
Okay, well, first of all, again, thanks for having me. It was a big change for me, coming from the foundry world into the IP world, starting with physical IP, where it's still the closest to silicon technology, right? Again, in ARM, we are excited to work on the latest and greatest technology. I'm sure you have heard about EUV, extreme UV technologies at 7 nanometer and 5 nanometer. That's exciting in ARM. There are new IPs that we are doing as well in the non-volatile, embedded non-volatile area. We also have FDSOI, another differentiated process technology that also represents additional differentiation for both the IP and the foundry provider, right?
Yeah. So there's always a big focus to accelerate the mainstream mobile and IoT devices, and that's ARM's strength there. A lot of the ARM strength. Now, to accelerate that for better performance, low power, and power performance area, PPA is very, very important to designers that are interested in achieving during their design cycle. So what is the ARM Physical Design Group? What are their views? What are in this market driver?
Okay, so yeah, certainly I think there's a lot of limelight given to the mobile space, right? I mean, all of us carry at least one smart computing device, right? I carry 3, right? So high volume uses a lot of the latest process technology, latest ARM CPU cores, GPU cores, right? So those are extremely exciting. We also have heard the upcoming 5G technology that's going to increase the connectivity speeds and experience, right? So that's important as well, and we have solutions in that area. What's also important is the different other application areas. Infrastructure, for example, networking, data centers, huge because of additional data consumption, right? More bandwidth required. So for those considerations like performance per watt, with billions and billions of transistors, because some of these chips are huge, right? We know and have heard of autonomous driving. Again, that's pushing the limit of advanced technology. Considerations are slightly different there. Reliability is paramount. And then cars are becoming also extremely well connected. So there are talks of having 5G even, connectivity built in the electric cars, right? So that they can get updates over the air.
Right.
You mentioned IoT, so of course IoT is also very important. Expected to have trillions of devices out there eventually, right? Spanning wearables, smart city devices, smart home devices. So for those considerations are slightly different, talking about ultra low cost, ultra low power as well. So I think there are a lot of new use cases that will continue to allow innovation and also allow more design activities to take place.
Any new and exciting achievements here with the Physical Design Group at DAC 2018?
Yes. I think in the last 11 months plus in ARM, I think the team has done really well. We work with all major foundries, TSMC, Samsung Foundries, Intel Foundry, Global Foundries, and a long list of other foundries that we work with, right? With TSMC, we recently announced memory compilers that are foundry sponsored, and we were chosen as the preferred memory compiler supplier and partner with TSMC for 22 nanometer ULP and ULL, technology that's targeted for IoT and mobile devices, right? With Samsung Foundry, we also had a couple of, I would say, wins. We are now also the platform provider for 11 nanometer FinFET, 7 nanometer EUV, and 5 nanometer EUV with Samsung Foundry. So essentially, designs can start at 5 nanometer right now for lead partners. The most interesting news, I would say, is a new product line that we just opened up, MRAM. MRAM. So that is an embedded non-volatile memory technology. These days, I think usually the solutions are made available in terms of fixed instances, right? Macros of MRAM. We believe we are the first IP company that is providing a MRAM compiler. Right? Yeah, so that allows different use cases, right, of how MRAM can be used. We have talked to a couple of lead customers. They are extremely excited, like to know more, because it opens up again a different product architecture, if you will, right? It's almost like a sandbox for the designers to play with it.
Yeah. Right.
Yeah.
And what do you see going forward in 2018 for the physical design group? And why is it important to our audience here and yours?
Yeah, and you can see, I think what we are seeing is there are new, I would say, applications, things like cryptocurrency, right? Bitcoin mining. Some of these are kind of applications that we kind of did not envision them taking off, let's say, 3 years ago. It is really, really hot right now. So we're trying to understand some of these application challenges better, and we're translating some of these to new products. Right? The physical design group also has what we call POPs, P-O-P, Processor Optimized Pack, and we are retuning that to make them more relevant to different verticals. So, for example, you can imagine like a POP for automotive applications. How is that going to look like, right? A POP for modem, how is that going to look like? And we're going to fine-tune all of that to make them, again, better optimized. So plenty of work.
This is exciting, and you know, I'm glad you're in the right place. You. Thank you for taking a little bit of time, Kelvin. Very, very much appreciated. So for Kelvin Low, my name is Sean O'Kane. We'll see you next time on Chip Estimate TV.
Thank you. Thanks.